You write that the central question at the heart of your work, from biological systems to computational ones, is how do embodied minds arise in the physical world? And what determines the capabilities and properties of those minds? Can you unpack that question for us and maybe begin to answer it?
Well, the fundamental tension is in both the first person, the second person, and third person descriptions of mind. So in third person, we want to understand how do we recognize them and how do we know looking out into the world what degree of agency there is and how best to relate to the different systems that we find. And are our intuitions any good when we look at something and it looks really stupid and mechanical versus it really looks like there's something cognitive going on there? How do we get good at recognizing them? Then there's the second person, which is the control. And that's both for engineering, but also for regenerative medicine when you want to tell the system to do something, right? What kind of tools are you going to use? And this is a major part of my framework is that all of these kinds of things are operational claims that you're going to use the tools of hardware rewiring, of control theory and cybernetics, of behavior science, of psychoanalysis and love and friendship. Like, what are the interaction protocols that you bring, right? And then in first person, it's this notion of having an inner perspective and being a system that has valence and cares about the outcome of things, makes decisions and has memories and tells a story about itself and the outside world. And how can all of that exist and still be consistent with the laws of physics and chemistry and various other things that we see around us? So that I find to be maybe the most interesting and the most important mystery for all of us to well, on the science and also on the personal level. So that's what I'm interested in.
So your work is focused on starting at the physics, going all the way to friendship and love and psychoanalysis.
Yeah, although actually I would turn that upside down. I think that pyramid is backwards. And I think it's behavior science at the bottom. I think it's behavior science all the way. I think in certain ways, even math is the behavior of a certain kind of being that lives in a latent space. And physics is what we call systems that at least look to be amenable to a very simple, low agency kind of model and so on. But that's what I'm interested in is understanding that and developing applications because it's very important to me that what we do is transition deep ideas and philosophy into actual practical applications that not only make it clear whether we're making any progress or not, but also allow us to relieve suffering and make life better for all sentient beings and enable to enable us and others to reach their full potential. So these are very practical things, I think.
Behavioral science, I suppose, is more subjective and mathematics and physics is more objective. Would that be the clear difference?
The idea basically is that where something is on that spectrum, and I've called it the spectrum of persuadability. You could call it the spectrum of intelligence or agency or something like that. I like the notion of the spectrum of persuadability because it's an engineering approach. It means that these are not things you can decide or have feelings about from a philosophical armchair. You have to make a hypothesis about which tools, which interaction protocols you're going to bring to a given system, and then we all get to find out how that worked out for you, right? So you could be wrong in many ways. In both directions, you can guess too high or too low or wrong in various ways, and then we can all find out how that's working out. And so I do think that the behavior of certain objects is well described by specific formal rules, and we call those things the subject of mathematics. And then there are some other things whose behavior really requires the kinds of tools that we use in behavioral cognitive neuroscience, and those are other kinds of minds that we think we study in biology or in psychology or other sciences.
Why are you using the term persuadability? Who are you persuading and of what?
Well,
In this context.
yeah, the beginning of my work is very much in regenerative medicine, in bioengineering, things like that. So for those kinds of systems, the question is always, how do you get the system to do what you want it to do? So there are cells, there are molecular networks, there are materials, there are organs and tissues and synthetic beings and biobots and whatever. And so the idea is, if I want your cells to regrow a limb, for example, if you're injured and I want your cells to regrow a limb, I have many options. Some of those options are I'm going to micromanage all of the molecular events that have to happen, right? And there's an incredible number of those. Or maybe I just have to micromanage the cells and the stem cell kinds of signaling factors. Or maybe actually I can give the cells very high level prompt that says you really should build a limb and convince them to do it, right? And so where, which of those is possible? I mean, clearly people have a lot of intuitions about that. If you ask standard people in regenerative medicine and molecular biology, they're going to say, well, that convincing thing is crazy. What we really should be doing is talking to the cells, or better yet, the molecular networks. And in fact, all the excitement of the biological sciences today are at single molecule approaches and big data and genomics and all of that. The assumption is that going down is where the action is going to be, going down in scale, and I think that's wrong. But the thing that we can say for sure is that you can't guess that. You have to do experiments and you have to see, because you don't know where any given system is on that spectrum of persuadability. And it turns out that every time we look and we take tools from behavioral science, so learning, different kinds of training, different kinds of models that are used in active inference and surprise minimization and perceptual multi-stability and visual illusions and all these kinds of interesting things, stress perception and memory, active memory reconstruction, all these interesting things. When we apply them outside the brain to other kinds of living systems, we find novel discoveries and novel capabilities, actually being able to get the material to do new things that nobody had ever found before. And precisely because I think that people didn't look at it from those perspectives, they assumed that it was a low level kind of thing. So when I say persuadability, I mean different types of approaches. Right, and we all know if you want to persuade your wind-up clock to do something, you're not going to argue with it or make it feel guilty or anything. You're going to have to get in there with a wrench and you're going to have to tune it up and do whatever. If you want to do that same thing to a cell or a thermostat or an animal or a human, you're going to be using other sets of tools that we've given other names to. And so that's now of course that spectrum. The important thing is that as you get to the right of that spectrum, as the agency of the system goes up, it is no longer just about persuading it to do things. It's a bidirectional relationship, what Richard Watson would call a mutual vulnerable knowing. So the idea is that on the right side of that spectrum, when systems reach the higher levels of agency, the idea is that you're willing to let that system persuade you of things as well. In molecular biology, you do things, hopefully the system does what you want to do, but you haven't changed. You're still exactly the way you came in. But on the right side of that spectrum, if you're having interactions with even cells, but certainly, dogs, other animals, maybe other creatures soon, you're not the same at the end of that interaction as you were going in. It's a mutual bidirectional relationship. So it's not just you persuading something else. It's not you pushing things. It's a mutual bidirectional set of persuasions, whether those are purely intellectual or of other kinds.
So in order to be effective at persuading an intelligent being, you yourself have to be persuadable. So the closer in intelligence you are to the thing you're trying to persuade, the more persuadable you have to become. Hence the mutual vulnerable knowing. What a term.
Yeah, Richard. You should talk to Richard as well. He's an amazing guy, and he's got some very interesting ideas about the intersection of cognition and evolution. But I think what you bring up is very important, because there has to be a kind of impedance match between what you're looking for and the tools that you're using. I think the reason physics always sees mechanism and not minds is that physics uses low agency tools. You've got voltmeters and rulers and things like this. And if you use those tools as your interface, all you're ever going to see is mechanisms and those kinds of things. If you want to see minds, you have to use a mind, right? There has to be some degree of resonance between your interface and the thing you're hoping to find.